Hello, my name is Meredith Thompson,
And my name is Margaret Wang.
and today we're discussing our study, investigating how teacher educators implement and pre-service teachers respond to online simulations in argumentation-focused discussions. We are part of a team of people from different institutions, including ETS, Indiana University, Towson University, UNC, and of course, we are representing MIT today. This study investigates how an online clinical simulation can help pre-service teachers learn how to facilitate argumentation-focused discussions. Argumentation has been identified as an essential practice in both mathematics and science education. As a result, it's important for pre-service teachers to become proficient in leading discussions that engage their students in mathematical and scientific argumentation. Simulations are one way to develop proficiency in teaching and are increasingly used to help pre-service teachers learn new skills. Engaging students in productive argumentation is important in understanding, in helping students in sense-making in science and mathematics. Productive argumentation involves opportunities for students to construct and justify viable arguments, to offer rebuttals and counterexamples, to compare and critique each other's reasoning, and to persuade others to modify their initial arguments. Pre-service teachers need structured opportunities and time to learn how to facilitate argumentation with their future students. One viable approach for providing such opportunities is the use of online simulations where teachers can try out, and practice discrete skills. Simulations and teacher moments are usually comprised of 4 different phases, with each phase having a certain number of slides. There's a context phase, an anticipate phase with 2 to 3 slides, and an act phase with about 5 to 7 slides, and a reflect phase with 3 to 5 slides. Both science and mathematics standards identify argumentation as a key goal. The next generation science standards include engaging in argument from evidence as one of the 8 practices essential to science and engineering. And the Common Core math standards suggest students should be able to construct viable arguments and critique the reasoning of others. To support argumentation, the claims evidence reasoning framework is commonly used in science contexts, while mathematics educators sometimes draw from a slightly different scaffold: conjecture, justification, conclusion. Pre-service teachers learn how to start and sustain productive discussions in their classrooms by using techniques such as talk moves. Talk moves includes questioning strategies such as probing student ideas, pressing for examples, revoicing a part of students' ideas, encouraging peer-to-peer interaction, or focusing on a specific context of a complex task. Note that talk moves can also be used to support argumentation, but in this study, we classify any talk move that includes argumentation specifically as an argumentation scaffold. This study examines 2 teacher moment single user simulations: the keeping the heat discussion task and the facilitating student-to-student discussions on the rate of strawberry picking, that are intended to help pre-service teachers facilitate argumentation-focused discussions in middle school science and middle school mathematics classes, respectively. Both scenarios have the same premise. The pre-service teacher takes on the role of a teacher who assigned a problem about the rate of strawberry picking in mathematics, or a question about an investigation of which of 2 types of cups will keep hot chocolate warm the longest in science. They present this to a class of fictitious middle school students and ask the students to explain their thinking. In both scenarios, the pre-service teacher is giving the written work of 2 hypothetical students who have written out their thinking to these 2 problems. Each fictitious student's profile is designed to approach the problem or investigation in a different way. The profiles also show how the virtual students disagree with their partner's thinking. The simulations are designed to enable the pre-service teacher to prompt the students to both compare and critique each other's thinking, even though both students may arrive at the correct answer or have the correct conception, they still disagree on the process they used to arrive at the conclusion or the evidence and reasoning they used to justify their claim. Here we show screenshots of the simulation at the enact phase of the teacher moments simulation. The pre-service teacher is prompted, what are some question of prompts you can use to help student A and student B share their ideas with one another? And what are some questions or prompts that you could use to help student A and student B critique one another's ideas? The pre-service teacher presses the record button, which is the microphone button, and records their response. And then that response is transcribed, and that's what we use to analyze. From the enact phase of the teacher moment simulation, we focused on one key question. Specifically, we investigated how pre-service teachers responded to the simulation prompt. What are some questions or prompts that you could use to help student A and student B critique one another's ideas? Now I will pass it to Margaret, who will continue with our research questions.
So our study had 3 main research questions to answer. Number 1, how do teacher educators introduce and frame a simulation designed to help pre-service teachers facilitate argumentation-focused discussions? Number 2, to what extent did PSTs use specific talk moves in their teacher moment simulation responses? Did the teacher educator framing impact how frequently pre-service teachers use talk moves? And number 3, to what extent did pre-service teachers use specific argumentation scaffolds in their teacher moment simulation responses? Did a teacher educator framing impact how frequently pre-service teachers used argumentation scaffolds? We conducted our study in 4 different secondary education methods classes at 4 different universities. The classes were taught by 2 math teacher educators, referred to as Math Teacher Educator 1 and Math Teacher Educator 2, and 2 science teacher educators, referred to as Science Teacher Educator 1 and Science Teacher Educator 2. Of the pre-service teachers in those 4 classes, 38 consented to participate in this study. 25 pre-service teachers were enrolled in a mathematics methods class, and the other 13 pre-service teachers were enrolled in a science methods class. 95% of participants self-identified as white, 5% as Asian American, 5% as Hispanic, and 3% as Black. 68% of participants self-identified as female, and 32% self-identified as male. The primary artifacts and data used for the study came from observation of teacher-educator classes each time argumentation was taught. Researchers also collected pre-service teachers' written assignments about argumentation, and researchers collected pre-service teachers' responses to the teacher moment simulation. Pre-service teacher responses were verbally given during the simulation and then transcribed and coded by researchers following the process shown below. Our coding system was based on an existing rubric, which was developed by other members of the research team for a prior research project. The initial rubric identified 5 dimensions of facilitating argumentation-focused discussions. Number 1, attending to student ideas. 2, facilitating a coherent and connected discussion. 3, encouraging student-to-student interactions. 4, developing students' conceptual understanding. And 5, engaging students in argumentation. The adapted rubric has 9 codes, which are numbered with the associated rubric dimension. We omitted the 4th dimension about conceptual understanding because the simulation was specifically not focused on developing content knowledge. In the simulation instructions, pre-service teachers were explicitly instructed not to check if students were using content-specific skills correctly because we wanted them to focus on how to engage with students in discussion with one another and in the practice of argumentation. We grouped the codes into 2 categories. Talk moves codes were linked to the rubric dimensions 1, 2, and 3, and argumentation scaffolds codes were linked to rubric dimension 5. The first 4 codes are connected to talk moves and focus on how the pre-service teacher addresses the students, brings in a topic area, and encourages interaction among the students. The second set of codes focuses on features of argumentation. Whether the pre-service teachers incorporated argumentation-based language and prompted students to engage in persuasion, justification, and critique. The final code was designed to track a particular type of pre-service teacher response, where some pre-service teachers encouraged their students to use ideas from others, whether it was trying out the other students' mathematics, problem-solving technique, or their scientific reasoning. While this code was designed by the researchers for this study, it still fell under Dimension 5 of engaging students in argumentation in the original rubric. Our first research question asked, how do teacher educators introduce and frame a simulation designed to facilitate argument-focused discussions? To answer this question, we investigated and observed how teacher educators framed a teacher moment simulation and their classroom instruction directly before they introduced the simulation. Mathematics teacher educator 1 and science teacher educator 1 both framed the introduction to this simulation in terms of argumentation. The math teacher educator assigned the article Advice for Mathematical Argumentation for homework and led a class discussion on the question, what is mathematical argumentation? The science teacher educator introduced the simulation using the claims, evidence, reasoning, argumentation scaffold. In contrast, mathematics teacher educator 2 and science teacher educator 2 framed the introduction to the simulation in terms of talk moves. The math teacher educator read a chapter from the book 5 Practices for Orchestrating Productive Mathematics Discussions, while the science teacher educator gave examples of different talk moves pre-service teachers could use when facilitating an argumentation-focused discussion. To answer our second research question, to what extent did pre-service teachers use specific talk moves in their teacher moment simulation responses? And did this teacher educator framing impact how frequently pre-service teachers use talk moves? We analyzed the pre-service teacher responses to the teacher moment simulation. We did not detect a discernible pattern between how teacher educators framed the introduction to the simulation and a frequency of talk moves among the pre-service teachers in their classes. However, we did find that across all talk moves codes, science classes had a higher occurrence of talk moves than mathematics classes. We also noticed that of the talk moves codes, there were lower rates of asking students to connect ideas or to interact with peers than there were of addressing the topic specifically and using student names in pre-service teacher responses. For our third research question, we focused on argumentation scaffolds and asked, to what extent did pre-service teachers use specific argumentation scaffolds in their teacher moment simulation responses? Did the teacher educator framing impact how frequently they used argumentation scaffolds? Again, we detected no pattern between how teacher educators framed the lesson and the frequency of argumentation scaffolds codes in pre-service teacher responses. Overall, science pre-service teachers more frequently used argumentation-specific language and had students use each other's ideas more frequently than math pre-service teachers did. On the other hand, mathematics pre-service teachers were more likely to invite persuasion, justification, and critique of student ideas than the science PSTs were. Another finding was that while critique was the most common code in argumentation scaffold set, some pre-service teachers expressed hesitancy to ask students to directly critique one another's ideas. One pre-service teacher contended that asking students to instead consider the perspective of the other student would help students better understand and analyze the problem. This strategy of using the other student's ideas was used by over half of science pre-service teachers and almost a quarter of the mathematics pre-service teachers. While the majority of pre-service teachers did use critique in their response, this suggests that a subset of pre-service teachers may feel uncomfortable leading discussions that include critique and may need additional support in incorporating critique in their own teaching. The major findings of this study are that pre-service teachers use talk moves and argumentation scaffolds in their simulation responses to varying extent and differ based on whether they were taught in a scientific methods class or a mathematics methods class. In addition, simulations can be helpful learning tools. Simulations allow teacher educators to evaluate pre-service teachers' progress towards facilitating argumentation-focused discussions and can serve as opportunities for pre-service teachers to practice facilitating argumentation-focused discussions in a focused online space.
We want to acknowledge the supporters of this work. This work was supported with funds from the National Science Foundation DRK-12 Online Practice Suite Grant, as well as the Professor JCR Licklider Endowed Undergraduate Research Opportunity Program UROP Fund at MIT. Thank you very much for listening to our presentation. And we will, if you'd like to ask us questions, we will provide an email in the paper.